Welcome. In this video, we'll be finding the area of a regular polygon given its side length, part 3. Let's take a look at our example. Example, find the area of the regular polygon shown below. Let's take a look at what we're given. The first thing we're given is that we're dealing with the regular polygon, so that means that all sides are congruent and all interior angles are congruent. In addition, we're given the side length here. Notice that each side measures 3 miles. Let's go ahead and count the number of sides. We have 1, 2, 3, 4, 5, 6, 7. So we're dealing with the regular heptagon, and we know that n is equal to 7. We know that the side length is equal to 3 miles, so we can come up with the perimeter, which is the product of the number of sides and the side lengths, which in this case is 7 times 3 miles, which in turn becomes 21 miles. Now, what we need to figure out is the apothem. Remember, the apothem is just the perpendicular segment going from the particular center of the polygon to one of the bases. So let's trace that perpendicular segment here, and we are in need of finding the actual length in there. So what we're going to do is trace a radius here as well, and we're going to use trigonometry to be able to come up with the value for the apothem. Okay, so in this case, I'm going to call this the apothem, and we need to figure out what is the measure of this angle that we're going to bisect by the radius. To do that, let's find the sum of interior angles of a heptagon. So sum of interior angles is given by the formula 180 times n minus 2. In this case, n is equal to 7, so let's go ahead and substitute that in. So we have 180 times 7 minus 2, so that's 180 times 5, which in turn gives us 900 degrees. So the sum of interior angles is equal to 900 degrees. So what's the measure of one, just one interior angle? Let's go ahead and figure that out. So each interior angle measures, in this case, 900 degrees divided by the number of interior angles, which is 7. And this is not necessarily an integer, so we're going to leave it as a fraction, okay? Now, that's the measure of this angle, the whole angle, so we're going to split it up into two parts. So we can say that if we wanted to cut it out, bisect it, this tiny angle in green is going to be half of that. So the angle in green is going to be 1/2 times 900 divided by 7, which in turn becomes 450 divided by 7 degrees. Okay, let's go ahead and extract that piece. Let me go ahead and copy this particular special triangle. So we're going to have this scenario. Here's the radius, here's the apothem, and here's part of the base. Now, let's go ahead and write down everything that we know. We know that this angle is 90 degrees. So let's go ahead and trace a 90-degree angle there. We know that this is the apothem. Now, the base of this little triangle is half of the base, or half of the side length. Since the side length is 3 miles, we know that this is going to be 1.5 miles. We also know that this angle here is equal to 450 divided by 7 degrees. And now we're going to be using some trigonometry. Let me go ahead and circle my angle and label the parts. So notice that this is my opposite leg. And this one over here is my adjacent leg. So we're dealing with a trigonometric ratio using both opposite leg and adjacent leg. Well, that happens to be tangent. So we can say, therefore, a tangent of 450 divided by 7 degrees is equal to opposite over adjacent. So let me write that down. So we have tangent of 450 divided by 7 degrees is equal to the opposite, which happens to be A, divided by the adjacent, which is 1.5. Now my goal is to get the apothem by itself. So what I'm going to do simply here is to multiply both sides of the equation by 1.5, so I can get the apothem by itself. Notice that 1.5 divided by 1.5 is 1, and 1 times A is simply A. So I'm going to get A is equal to 1.5 times tangent of 450 over 7 degrees. Okay, now we have the apothem and we also have the perimeter. So we can say, okay, the area is equal to 1/2 times the perimeter times the apothem. In this case, we have 1/2 times the perimeter, which we found it to be 21 miles, times the apothem, which we found it to be 1.5. Let me put an asterisk here to indicate multiplication. So we have 1.5 times tangent of 450 over 7 degrees. Now let's go ahead and enter all of that into your scientific calculator. Just make sure you're on degree mode, and you should get that this is about 32.71 square miles. So you can say, therefore, the area of the heptagon, in this case the area of the regular heptagon, is about, or approximately, 32.71 square miles. And that's how we can find the area of a regular polygon given its side length. Thank you for watching and have a wonderful day.